Here's a typical watch. In fact, that was a watch issued for our area, tornado watch. Typical size. You know, sometimes the watch is there. We have storms moving in, but sometimes, and I think this was kind of the case initially last Thursday, we didn't have hardly anything. I mean, it's possible that the watch could be out and there is not a single storm anywhere within hundreds of miles. But the watch, again, is there because we know conditions are favorable for severe weather. It doesn't mean that it's already happening somewhere. You know, it may just, it's still, the atmosphere is still priming up for it to develop. And so the watch is issued. As far as the watch, you know, check it. That's a time you should consider activating or getting ready to activate. You just simply needing to get out from the spot. You can still stay attuned to the, and I'll talk a little bit more about these, the mesoscale discussions, the Storm Prediction Center issues during the watch stage, and the outlooks too. Those could change and provide some additional information. Are there any storms yet? Look at the local storm reports. You're here in Southern Illinois, be watching what these storms are generating out in southeast Missouri that are moving ahead of you. You can get all that information off of our website. Short-term forecast, the graphic nowcast, we do those very regularly. They're on our website. We tweet them out every single time we do them. We put them on Facebook every time we do them. Just another good way to stay up to date. And we started something new with those too this week. We got permission and we now can do our graphic cast with radar scope. Does anybody in here use radar scope? Okay. A couple of you, that's a software. It's very easy to use. You can get it on like iPhones, iPads. I think can't you get it on, put it on, don't they have it for Droids now too? Okay, yeah, you just got it there. There's other kinds too. We can't endorse any particular kind, but that's a commonly used one. You know, there's WeatherTap, there's GR Analyst, which is a very savvy, and it's really a higher end as far as you want to really dig in to storms vertically and that kind of thing. There's a bunch of them out there, but there's lots of good information.
When I started out using Storm Predator, which is about $50. And then I went up to Interwarren Storm Lab, which is about $100. But so far, I found that has been a good software for somebody who just doesn't have a lot of money, you know, to be out there.
So which one, Interwarren or?
Interwarren Storm Lab is a really good one.
Yeah.
I mean, it's pretty accurate.
Yeah. Yep, it is. I've looked at that too. I haven't looked at it in a while, but they've got some good information.
Yeah, it's been pretty reliable for me.
Yeah. So there's a lot of there's really good radar software out there, and a lot of them you can, if you're like driving out and about, you know, you can push a little button, it'll put a little dot or circle where you're at, so you'll know in relation to the storm, which makes a good safety thing. I use it when I'm driving. If I'm in a storm, you know, I might be producing hail or something, I get off the interstate and let it go by and go on, you know. So there's a lot of good tools out there now. It's unbelievable what we have compared to what was available even just 4 or 5 years ago. But just stay up to date with all the different things, different sources of information you have there at your disposal. All right, here's another watch, a tornado watch. Once you see a watch on the website, depending on how you're going to look at it, it will be on the front page of our website. You can get it right from the front page of the Storm Prediction Center website. But once you click on the watch, you'll get a map like this come up, show you the exact counties in the watch along with the radar data. And there's also a little chart that I like down here at the bottom of every watch, and it's got all the different elements, severe weather elements down here, tornadoes, but it's got it subdivided into EF2 and above tornadoes, severe wind, again, 58 mile an hour stronger. But it's also got the 65 knot wind, which is actually 75 miles an hour. Well, I said that earlier. Severe hail, which is 1 inch, and then the 2-inch hail. So they tell you what the risk is, or the level of probability, likelihoods with the term they use there, of each of those different elements occurring within this watch area. So, again, just another way, but now in the watch stage where you can get additional information that's pretty handy, really. I want to mention this, one thing that this is a brand new change just this week. It's really not that big a deal, but starting now after April 14th, they're adding a summary to the tornado watches. And they're actually moving, they had a longer discussion at the bottom of the watches, and it's going to go into the mesoscale discussion product that I mentioned a minute ago. And we'll talk more about those in a minute. But just know that the watches, a little bit of a change there. They're going to go to a shortened summary product and push the information, the discussion information into the discussion product, the mesoscale discussion. All right. There are essentially, really we're increasingly doing this, whether we even kind of realize it or not, but we're kind of tiering our products more and more. Just like the outlooks, you have all the different tiers. Really, the watches really are tiered too. We don't really advertise this, but I think it's very important for you all as spotters to realize this. We have the regular tornado watches, and then we also have the higher end tornado watches, which are called what?
Potentially dangerous situation.
Yeah. Particularly dangerous situation watches, or PDS. Why we call it PDS, because I wouldn't say that every time. So we have the PDS watches. All right. So I did a sampling the end of last year of our last 50 tornado watches up through last year. Of those 50, 46 were in the regular category, and 4 of them were in the PDS range. And basically, it's kind of like the outlooks. You have the hatched area. It's kind of like a hatched watch, if you will, because it's where we expect that big stuff could occur. The strong and the violent tornadoes in the case of a tornado watch. So 4 out of 50, less than 10%. That's a sampling, but that was our last 50 watches. So it's probably going to hold, in that general range if we do 100 or whatever watches. Here's again, a regular watch. It just says tornado watch up here. This is not a PDS watch. A little bit longer maybe than some watches north to south there. But again, here you have the likelihood for the different categories at the bottom. And notice they're mostly all in the moderate, the low for the 2-inch hail. The severe wind is high. Even though it's a tornado watch, the severe wind, non-tornadic winds, they've got that high. And I'm pointing those out because I want you to see the kind of the difference between those for a regular watch and for a PDS watch. And again, you get those at the Storm Prediction Center website, or you can get them from our website by clicking under Current Hazards. And plus, if there's a watch in effect for your area, if you just click on our map on the front page of our website, any watches or warnings that's in effect, it's going to pop up just by clicking on your location on our map. So there's numerous ways to get to everything. I already pointed that out, and I'm just going to mention there's even additional detail you can get down below this little chart here on all the watches. If you want to dig down, you can find the exact percent for tornadoes of F2 or greater intensity. It's got 30% probability of that. All right, so here is a PDS watch. This was actually one issued for our area, and it very plainly, it's not circled, I circled it there, but it is read just like that on the Storm Prediction Center website. It says particularly dangerous situation. Can't miss it. And if you look down here, everything's moderate to high. So, they've got high for tornadoes and high for EF2 tornadoes. And that triggered them to do a PDS tornado watch. In the text product that they issue, anytime there's a watch, you can look at the actual wording and text that I showed earlier as well. But if it's a PDS watch, it's going to have this in here. So in other words, if you just look, you can't miss the fact that it's a PDS watch, okay? And not to mention that the wording in the watch is going to be bad too. It says destructive tornadoes, large hail, etc. Destructive tornadoes is generally only used for strong and violent tornadoes. And here's this chart down here again, just to point that out. In this case, I think that's 50% of the tornadoes, significant tornadoes there they have with that PDS watches. Okay, now severe thunderstorm watches. We have the two types of watches. We have regular severe thunderstorm watches. How many of you knew we had PDS severe thunderstorm watches? Okay, 2 of them. And when I sampled those, of the last 50 of those, only 2 of them were PDS severe thunderstorm watches. So 2 out of 50. If you take a sampling of the tornado and the severe together, that's only 6 out of 100 that were in the PDS range. So I'm telling you, if you see PDS, it's not a guarantee things are going to, necessarily be worse, but the atmosphere definitely has the capability to produce worse tornadoes, worse damaging thunderstorm winds, etc. So take alert, take notice if you see a PDS watch, because they are obviously very rare. So here's the actual PDS severe thunderstorm watch. This was just outside of our area, but this was for the event that hit our area, the May 8, 2009 super derecho. I'm sure nobody remembers that. So that's, that's the kind of event that's deserving of a PDS severe thunderstorm watch. So, in this particular thing, the threat of strong tornadoes was very low, but even the 65 plus knot wind threat was was the highest level there. And here it is, the same watch, just the wording of extremely damaging thunderstorm wind gust 80 miles an hour. And even that was obviously underdone, wasn't it? We're here over there looking at damage from that event. Here's a discussion from the watch, and now, actually that will be in the mesoscale discussions with the watch, as I have up here. But large cluster of intense convection over southeast Kansas will likely organize in Paducah this morning and race east-southeast across Missouri, Oklahoma, Arkansas, and that was just for that watch period, but obviously on to the east after that, to southern Illinois. By the way, that was issued by John Hart. Did anybody make it to the 90-year anniversary of the tornado event? He was our keynote speaker there, and he is a storm prediction center lead forecaster. He's from southern Illinois, which is why I asked him to come. He's from Mount Vernon, from that area, so it was a real rare treat to have him. Here is a PDS tornado watch. I think I just accidentally put that in there twice, but here's a mesoscale discussion. Anytime you see MD or MCD, it's the same thing. It stands for mesoscale, which is basically a scale that encompasses the size of a region about like this. It's pretty typical. Synoptic scale is like bigger. That's like, the whole U.S. or a big part of the U.S. kind of thing. But the reason I mention the MDs is there's really some good information you can glean out of those. Like here in this one, and they always have the text and they have the graphic. Even if you just look at the graphic, you get some good information, because a lot of times they'll say, considering tornado watch and it's right across southern Illinois, you have, some updated information about, what's could be coming. So here they say severe threat increasing across southern portions of weather watch 25. New watch may be needed shortly. Greatest potential for intensification downstream. Downstream always means generally in the direction the storms are moving, so that would be to the east or northeast, moving northeast. And here is another mesoscale discussion. It says severe threat, damaging winds and tornadoes expected to spread into the mid to lower Mississippi Valley and lower Ohio, Tennessee valleys, which outline southern Illinois there. And then here's the actual text to get some more detail from that. Let me just show you real quick, just so we're clear on that, where you can Now, on the mesoscale discussion, we'll have a probability of watch issuance. That one, particular one is 60%. So, you know, you can see what SBC's thinking. They've got 60–80%, you know, I'd be kind of pretty much planning on it happening. But sometimes they'll even put 30 or 40% in watch, and issue a watch. So, just another source of good information there for you. All right, any questions about the watches before we move on to the warnings? All right, we're in the warning stage. At that point, you, the spotter, you're going to be monitoring everything you can, just like you have been. Weather radio becomes an increasingly valuable tool, I think, especially if you're out doing some mobile spotting. Radar is definitely something you want to hopefully have access to when you're out there. All the local storm reports that I just showed you to see what other spotters nearby are reporting, to know what's coming your way. And, you know, just listening to the warnings and the statements from the warnings, I have that information in there. Any updates to the forecast, the graphic cast, etc. Utilizing to make your reports, the eSpotter submit a storm report thing I just showed you, etc. And here's, you know, even in the warning stage, you know, there's kind of sometimes storms we're more concerned about. And this is a graphic cast I got from the Jackson, Mississippi Weather Forecast Office. I thought was pretty good. And actually, we're doing a lot more in graphic cast now than we used to at our office. I probably could get some very similar examples here. But this was a really bad day. There were 2 or 3 supercells across Mississippi. And so they said particularly dangerous situation unfolding across the region. Been interesting to know. I don't know if they had a PDS tornado watch. I wouldn't doubt they did. Actually, you know what? I think this is the, I'm pretty sure this was the April 2011 outbreak, come to think of it. So I'm sure that there were PDS watches out that day. But I thought that was some good information at the warning stage. They have warnings in effect. And with that graphic cast, had some really good information there. But one thing we've done, and we kind of, just like I've been talking about, the same thing with the outlooks and the watches, we basically kind of tiered our warnings down. We tiered them based on the impacts. If we expect, you know, worse storms and bigger impacts, we want to let everyone know that. We started that 2 years ago, and you may not really be, you may know about it in a little bit. You've seen it probably or heard it, but you may not really realize what it was. But the bottom line is we have new wording in our warnings, and at the bottom, just at a bird's eye view or a glance, you can know exactly what level of concern we have for a given warning, or when we issue the warning. When we issue a tornado warning, we're always going to have one of these 2 options tagged at the bottom of every single warning. Every one. It's going to say either tornado, ... radar indicated, or tornado, ... So initially we'll say radar indicated, and that I guess would be the ideal scenario where we're seeing the circulation up high. But then we get reports from you, the spotter, and then we update the warning and essentially have tornado observed at that area. So again, this top tag here for tornado warnings is always there. This second tag, tornado damage threat tag, is virtually never there. It is a bad situation if there's a tornado damage threat tag. Okay? Most of the time, no tag. But if we expect, if we have credible evidence that a tornado is occurring and producing considerable damage, we can use a tornado damage threat tag and the tornado damage threat considerable. All right. Then, if there's a situation like a Joplin, Missouri situation, we can use the tornado damage threat tag catastrophic. Now, there are no false alarms with catastrophic. That would have to be something like, you know, say if we had a tornado warning with a catastrophic tag on it for here, that would have to be like, we've got multiple spotters in Carbondale reporting how, you know, numerous houses leveled in a tornado. A violent tornado heading this way. We have to have that information. We cannot issue a tornado damage threat tag for catastrophic unless we've got catastrophic, house leveling type damage occurring. And the considerable is a little less constraining than that, but it's a bad situation too. We looked at several events over the last quarter century or so in our region, and there's really probably only 3 or 4 that we could have used a considerable tag with, and really none the catastrophic, outside, of course, of the tri-state tornado of 1925. That certainly would have needed the catastrophic. We could talk about the Marion tornado here in 1982, and some of the others would be in the discussion, at least with a considerable tag, but in the Harrisburg tornado, but it's very hard to even get to the considerable tag. So if you ever see that, it's got to be a really bad. Just note also there's a hail tag at the bottom of the warnings to indicate what size hail we expect. Okay, any questions about the outlooks, watches, or warnings? It's basically the new part, or added part, for the time. All right, we'll go here just a little bit longer and take a break, and here in about 15 minutes or so. But I want to go with the 101, and I'll just tell you this next section is some stuff there's several things in here that's on our little quiz at the end tonight. But we'll talk about some of the different weather elements, and of course, there's temperature, there's pressure, there's wind, there's moisture. We talked about that. And all the kids in school learn that now, the basic elements of weather. We're going to break down each of those and talk about them in detail though. Starting with our seasons. And the bottom line is we have weather because the sun heats our planet unequally. And that unequal heating causes these different parameters to vary across our planet and causes the weather that we have. A few notes is the sun's radiation only reaches half the planet at one time. Obviously, the other half is dark as we're getting ready to be here. And the amount will vary depending at different locations because of the tilt of the Earth. You've got more atmosphere to go through in some areas as well. And that makes a big difference is how much atmosphere you have. The sunlight has to travel through to get to the ground here. As a matter of fact, if you think about it, when is the sun closer to us in the winter or the summertime?
Summer.
When is it bigger? When do you, I hope you don't look at the sun directly. when is it look bigger in the wintertime or summertime? Winter. It looks bigger in the wintertime than the summertime. So just from that, if you just consider that, you think, well, it's going to be hotter in the wintertime because it's closer. But it's not. It's because the sun has more of the atmosphere to travel through than it does in the summertime. So that's what makes the difference. That all has to do with the Earth rotating around the sun and the angle, and therefore how much atmosphere the sun rays have to travel through. Another fact is that land warms and cools faster than the bodies of water. That comes into play, especially if you're along the Gulf Coast. You'll get the land breeze and the sea breeze because of that differential, the land cooling and heating faster than the ocean. All right, air pressure is a measure of the weight of the atmosphere on top of us. It is one of the key elements of weather. And one of the key things is air is going to travel always from high pressure to low pressure. It's, a very basic principle. You blow up a balloon, it's got high pressure in it, and you release it, it's going to go out of there to the area of lower pressure, which is all around it. But it doesn't go straight from high pressure to low pressure in our atmosphere. The reason is because of the Coriolis force that we have with the Earth spinning. And that causes the air to be curved as it goes from high pressure and feeds into low pressure. And since you have air coming all around and rotating into low pressure, you have all that volume of air. It has to go somewhere, so it goes up. Okay, can't go down, it can only go up when it's all coming together. When it goes up, and it's generally higher moisture air, and it goes up, what does it do? It condenses and forms clouds, and if there's enough of it, that moisture, then it forms precipitation. And that's why we have precipitation more associated with low pressure than high pressure. And if you ever hear us talking about, like in the forecast discussions and all, ridges and troughs, troughs are areas of low pressure in the upper atmosphere, and ridges are areas of high pressure in the upper atmosphere. That's how we refer to it there. Occasionally we have a closed low, we actually call it a low in the upper atmosphere, but a lot of times we just call it ridges and troughs. We don't mean like a, we're actually not supposed to use that in our discussions and all, because it can be confusing, and some people probably think it's a cow trough or whatever. Right? All right, so why do we have wind? I already mentioned the one force, and the name of it is pressure gradient. That's the balloon type thing where the pressure is greater in the balloon, and that gradient force lets it come out of the balloon. But due to the spin of the Earth, the air turns to the right in the northern hemisphere again. The Coriolis force is what causes that. In the southern hemisphere, it's basically everything's the opposite. I could never do weather in the southern hemisphere. I stay. And then we have friction. You know, all this stuff out here, these trees, these buildings, slow the wind down, slow the air down. That's generally why it's windier in the plains. You don't have all the friction out there like we have here to slow the wind. All right, moving on to moisture, and there's dew point, and there's relative humidity. But it's actually the dew point, which is defined as the temperature to which air must be cooled to be saturated, that is used mostly by meteorologists. We like using the dew point. We do use the humidity some, like for fire weather forecasting, but most of the rest of the time we use relative humidity. It's just to let the general public know. But you don't hear us talking about it in the office much. We're talking about the dew point. And it's a specific level of temperature. Again, the temperature at which the air must be cooled to be saturated. If the dew point increases, it's only because the amount of moisture in the air increases. So it's a direct correlation to how much moisture is in the atmosphere. So that's why we like it. Dew points, you know, below 50 or so is comfortable any time of the year. You start getting in the 60s, you can feel the moisture, you know, in the atmosphere. 70s, lower half of the 70s is not comfortable. That's when you sweat a lot and you're not boiling. And it's absolutely miserable by the time you get to the mid or upper 70s. That's that really bad that you drip when you just walk out to get in the car out of the days. But believe it or not, and the highest dew point I've ever been in is about 82 in my whole life, which is really high. But there was a place in Saudi Arabia, Iran, Saudi Arabia, supposedly they reported a dew point of 95 degrees, and with a temperature of 108. Now I can't imagine that. That to me that would be like instant death. But I lived in Mississippi, and we had a dew point in the lower 80s and the temperature in the upper 90s, and the heat index was 126. And I mean, I got nauseated just walking outside the building out to my car. Just, I mean, not bad, but just kind of a nauseated feeling from that. And I just can't imagine getting any higher than that. It just, I don't see how people could live in that very long, honestly, at all. If you didn't have air conditioning, I would think even a healthy person would succumb to that kind of heat pretty quickly. Air masses are large bodies of air with generally the same temperature and humidity qualities. Okay, that's all it is. The air becomes similar to whatever it's over. So if you have air over the Gulf of Mexico, it's going to be, become high in moisture and warm. If it's over Canada, it's going to be cooler and drier generally. So it takes on the characteristics of wherever it's at. Then once it starts moving into another area, it brings all those same qualities to that area. And once it does start moving, the leading edge of that moving air mass is a front. It's the boundary between the air masses, and it helps us determine where the leading edge of that area is located. And we have different symbols that I'll go over to help us determine that. But one of the main quantities that we measure is the temperature. And cold air has more molecules, it's heavier, warm air, fewer molecules, and it's lighter. So that's how we measure the different air masses, or the boundaries between the fronts. And of course, warm air rises and cold air sinks. Even in this room, if there was no air movement at all, you could measure a warmer temperature up at the ceiling than you could down here at the feet. You know, maybe only a degree or two or whatever, but it definitely would be warmer because of that natural state of the air movement. Warm air rising, cold air sinking. Here's a cold front, a blue line with the blue triangles on it, colder air back behind it, behind the triangles. And there's a little animation of it advancing. It hugs the ground pretty tightly. It causes air to move up ahead of it. That's where you get clouds, and eventually you can get precipitation and even thunderstorms because of that. Cold fronts, of course, are famous producers of lines of storms as they move across the area. Sometimes the air mass is very pronounced in the wintertime, like here. You know, it's 36 in East Central Illinois, 64 in Cincinnati, and Louisville, 28 in St. Louis. You know, it's very easy. I mean, you can pick out, you know how it is. There's times you can pick out it's 65 degrees on the warm side of the front, and 8 or 10 miles back, it's, you know, 40 degrees or something. Very distinct, very sharp cold fronts sometimes that we get in the fall, winter, and spring. Then there's warm fronts, and that's where the warm air is trying to scour out all the cooler air. Sometimes it can be a little bit more of a process to do that, because sometimes the cold air is kind of stubborn or is more dense and hugs the ground. But that rise there does create clouds and showers. And here's what a warm front looks like. It's always red. It's got the half round shapes on the colder air side of the front. Warmer air is back behind it. Because the warm front typically is moving in a northward direction. Warm air is to our south generally, and colder air is generally to our north. Then we have fronts that nothing is moving. Therefore, we call them stationary fronts. And they look like this here. They're just a combination of the red and the blue. But nothing is happening. Sometimes upper level winds is running parallel to the front, and that keeps the front from pushing in one direction very much at all. But you can still get weather along the stationary front. So a bird's eye view. Of course, your low pressure system here, your warm front generally is draped off to the east or southeast, and the cold front trails south, and usually back in a westerly direction. Cold air behind it. You may get some showers and storms. You can even, in some cases, get tornadoes along warm fronts, and definitely get showers and storms along the cold front. If these come together, and this is not anything you really need to know, but if these come together and the low really gets mature, they come together, these two fronts, we call it an occluded front. You don't have to know that, but